Hi guys, welcome to the Neuroscience channel. Today you can see a boat over here with a humanoid face, some motors and some paddles and all that. Well, are you interested? Today I made an invention. This is a solar powered humanoid boat. It looks like a human in a side view. Plus it works solar and has a motor that's this much small. It's called a coalesced motor. It's the breadth of it and the length of it is somewhere like this. It has very low torque. Anyway, what's torque? All that will be covered in today's episode. Now, how does a solar panel work? That also will be covered. So, today two topics and other topic come right up. So, what are the two topics? How does a solar panel work? And its name is photoelectric effect. And the second thing is torque. Torque. What's torque? Well, torque is something that's with gear ratios and strength. Getting confused more? Well, let's jump in. So what's torque? If you have a coalesced motor, probably who sees this video should know it, as you know. So if you have this motor, the coalesced motor, if you put electricity through it, it spins very fast. It can lift its own weight if you were to connect a fan to it. But there's a problem. If you were to keep your finger through it, it will stop immediately with no power at all. This is known as torque. Torque is the tendency of the spinning object to spin, and applied force will not stop it. Now if I have a door over here, let me draw a door. And this is the axis. Now what's an axis? Axis is an imaginary line that shows an object's spinning point. For Earth's axis is in its between. Our Earth's axis is in its between, and that's where the axis of Earth is. This is called rotation of the Earth. The rotation of the Earth occurs from the axis. So over here we see toe, the axis over here. It's not only in that case. If you have an instrument like this, which I believe many of the mechanical appliances and people who work in mechanical works should know this. This is what we use to remove nuts from car and many appliances that uses nuts. So when you spin a nut is something that holds a screw. So when you spin the nut, we spin it in this direction. This position acts like an axis because it doesn't move here. Over here, the nut is there, which this instrument is spinning it. The middle of the nut is called the axis. So this whole thing is spinning around this imaginary line called the axis. So why am I talking about this? Well, if you push this instrument over here, it's pretty hard to move the nut and spin it and remove it. But if I were to give the same force over here, that is far away, it is easier to do it. Why? This is something confusing, right? Well, that's torque. When you push here, the pressure of this nut cannot stop us from spinning it. So, when you spin it over from here, the torque is too high that the force applying on it in the opposite direction is less than the force given here. The force given here, for example, let's give it A. The value of the force given here is A. Let's imagine you are to see the force given here, it will be the same force given, that's A. But the action done is A2. But here, the action is just A. You give the same force to get double the action. Work, or I can say. So, A2, you can form more work with the same amount of force if you were to extend this. So, let's use this in gear technology. I have a gear over here. So you can see here gears, and there's a smaller gear in between it. I think it's used in many commonly. Not a good artist, but you get it, yeah. So here's a gear that's outside and a gear inside on top of it. So now I have another gear with me, a big one. So I put it over here. Pretty big gear. You can see from this drawings. I can't draw the spikes, okay? So if this is the axis of this guy, this, and the axis of this. Now, the opposing force on this is friction. Friction is reduced by oil. But if I had a smaller gear over here, let's put a smaller gear over here. Okay, and draw some spikes for this. Okay, now there's two things you have to know: horsepower and torque. You know what's torque, as I've explained it now. But what's horsepower? Well, how fast a work is done. The horsepower of something can be high, but the torque of it can be extremely low. Like how in the starting the motor spins very fast, but it can be stopped easily because it has low torque. That's the same imagining over here. So let's say this is the motor over here. This motor spins this gear, where there's another gear in between it. So I've connected a bigger gear over here. I'll give it a bigger gear over here. So now what happens is that, as we learned over here, the farther away you give the force from the axis, the more it spins, the more the work is done, and easier it's done. With the same force given near to the axis, the work, yeah, you get it, it's too hard. You have to give A2 to get A. But in this place, you need to give just the same amount of A over here as the force in the starting to get A2 easier. But there's a problem. The speed of this decreases. When you spin it from here, you need to give more pressure to more force to give one spin itself. From here, you need to give high force, but you need less time to give the pressure for one single axis spin, or you can say one rotation. Same happens here. Now, as you tell, this gear, the one that is on first, is connected to the motor directly, and this is the big gear. It's very similar to this. It's very similar to the same machine that I draw in the starting. The same. I'm just drawing. It's not there. I'm just drawing it for your understanding. It acts like this, and the tip of it acts like the gears are boundary. So when you spin this, it's very easy for the motor to spin it. So this motor spins one round. This motor spins less than a quarter rounds for this. As I told, horsepower decreases when the torque increases. Understand this. When it's like this, horsepower decreases whereas torque increases. So as you can see here, the motor spins this big gear easily. So the torque produced over here is very high. If I were to do this again, where I add another gear over here, and I connect it again to a bigger gear and repeat this, the final torque over here is so strong that the highest power you can give can barely stop this. This is known as torque. That's why I said in the starting, you need torque to move these parts. It's very high. Weight and all that comes, so gravity and all that stops it, and friction also is a main component in this. So you need high torque to cancel out or overthrow all of this friction, weight, gravity, and yeah. So these are main things that you have to know to know the gear ratio of this. If the gear ratio was right, you can make a beautiful working motor that gives higher torque than without the gears before the motor was ready. So torque is nothing but the tendency of the wheel to move even with an external force pushing it. So we can say this robot has a high torque. Now let's come here to this small gear that I brought in last. Now, if you see, this gear is smaller than this gear by somewhere like a centimeter. So as I told you, if you push it from here, it's harder. While you push it from here, it's easier. So in this case, it's like this is the axis of it. This is the axis of it, and this instrument is just this much tall, just this much, and you push it in the corner. In this case, it's very hard. It's as if you give the force over here that gives the job. You have to give A force to do the work, which even cannot move at times. You have to give more than A force, for example. A2, where in this case you can give A to get more easier job done, but the horsepower decreases. If I come here, it's like pushing it from here. So the spinning of this pushes this, and the gear ratio again comes in this place and decreases the torque and makes it harder. You can do this in your home right now. If you have the door, just push it from the doorknob given. It's very easy. Now push it near from the hinges. It's pretty hard. You can do it with one finger in the edge, and you have to give the two of your hand force to push it near from the axis. So if I add more and more like this, a smaller gear and a smaller gear and a smaller gear and a smaller gear, smaller gear, and it goes down, the speed over here will be so high. But first of all, there should be a force given here to spin this. The torque is so decreased that the motor cannot spin it anymore and clogs up. This is why there are gears in your car. Our car goes through high mountains, so it needs more torque at times, and more torque at times is bad because you have to go fast in highways and all that. So that's why there are many gears: gear 1, gear 2, gear 3, until gear 5, and more than that, I believe. So if you see a racing car, there are many gears. This is just because in a racing car, it has to start up. So for starting up, the torque should be high. So as it goes forward, the driver changes the gear to gear 2, then to gear 3, and it comes back to starting. This is because the car has to start going with a high torque, then it gets inertia, and then you can decrease the torque and increase the horsepower. So your racing car starts up a bit slowly, change the gear, make it go faster, and then you can continue and the car goes amazingly speed but with less torque. So this is what is torque. Torque is a tendency of something to spin, and when external force like friction, gravity, weight or something comes, its torque is enough or the tendency is enough to move even though if there was an external force like friction. So that's torque. We have done with the gearbox. Now what's next? Solar panel. So now let's go to a second topic, photoelectric effect. This was founded by Albert Einstein. He found this when he shined a blue light on a charged plate. When he shined it, immediately the blue sheet got discharged. This was called the photoelectric effect. This happens in many metals. He got the Nobel Prize for this because he proved that light is not a wave, neither a particle, but both. It's a combination of particle and a wave. This proves, and this proved science is called quantum mechanics. This is something which matters with particles, which all comes together towards light. All works with the help of light speed, light properties and all that. So now, what's photoelectric effect? The main point is nothing but when you shine a certain light, like how our sun contains UV light, and you shine it on a plate, the atoms in it gets to a higher charge. This makes an electron flow. You can do this by a simple way. If you have a sheet that is very attractive to materials, if you put tape under it and stick balls over here. Let's consider this as atoms. And now I have another ball over here. Let's name it P. Now what's P? P is nothing but photons. Photons come from our light. These photons come with some acceleration and hit an electron. Now what happens? This momentum, as we all know, is transferred to this ball and pushes it. But in the original case, there's no momentum. It's just in our case where we are doing it in a big range, you transfers the momentum to this guy, this ball, which is electron for us. So we'll mark it over here E. These balls are the electrons. So these are the electrons. So they get knocked. Okay. So now they want to go back. So, but they can't. That's how it works. They cannot go back. So we force them to go through a path. Over here, you just draw a bulb. It's a ball and this. And connect it back over here. So now this knocked off electron travels through this region, through the bulb, and makes it glow. Come back here and back to this region where how it was knocked off, it comes back. This knocking off electrons by the photons go through this connection, go through the bulb and back to its original position. This cycle creates an electron flow. If we have the right light in our house, you can make this work in your house itself without any sunlight itself. But most of the lights that we have now, like the tube light, doesn't work. Fluorescent bulbs do not work well with these guys. So, photoelectric effect is that when a photon hits an electron, it knocks it off. And there's something interesting also. When the electron comes back to its position, it releases some light. So in reality, it's gonna be like this. We have our protons, neutrons, not neutrons, of course, because neutrons are very rarely found. They're found in uranium and all that materials. Protons, nucleus, and then surrounded with electrons. This is just a configuration and not true. There are many electron rings going around, you can see. Each electron goes in a different path. This is not a perfect configuration, but you can consider these as electrons. Let's say it is E. So when photon, that's P, hits hits an electron, it gets knocked off. This knocked off electrons won't come back to its position, but it cannot. So it's separated by some materials so that it doesn't go back, and then it's forced to go through the wire and back to the atom. Before it goes, you can put some components over here. For example, we can put a motor over here. Just need to put a motor, and voila, the motor starts to spin. They can do many jobs, but the electricity produced is very low. Big solar panels does help, but its consideration towards battery is, solar panel over here is about more space needed than a battery. One battery is about smaller than these. Nowadays, 12-volt batteries come smaller than the size of a solar panel. But it's a greener way to produce energy. So, what is photoelectric effect? It's when photons knock off electrons and the electrons are forced to go through a circuit and pass through all the components, and then these components work and these electrons come back to its position in the atoms. This configuration can be done in your house. If you just have a sheet of cloth, just tape it to the cloth loosely and then take a ball, hit it hardly. You can, if not exactly like tennis ball or cricket balls, which will immediately, tear off the cloth, but something lighter, or you can say bouncy balls. They're like stress balls, emoji balls, and all that you get in shops. You can use that to hit it on the cloth. This transfers the momentum to this ball, which falls down. But remember, momentum is not transferred towards this. The photons knock off electrons. No momentum transfer in the original case. This is just how happens in reality. But this configuration can show somehow how solar or photoelectric effects work. Now, our next topic is buoyancy. What's buoyancy? Let's take a front view of this boat. Let's take one segment, this boat segment. Looks like this. This shape is why it's buoyant. Now, let's see. Our water is a fluid. What's a fluid? Fluid is something that pushes objects less dense than it. For example, if we have paper is very big, but its density is very low. One of the materials that I can tell is called aerogel. It's a material that's pretty light, but it's solid, and and it's a combination of solid and gaseous. It's like it's both. It's hard to define, Angel. It's we can say it's a combination of air and solid, which is something crazy and very lightweight. The area displaced is very high, but its density will be very low. That's called buoyancy. In this in this area, you can see the area displaced is from here. Is a measurement from here till here till here. Now, if I have a bowl, let's take a bowl. Imagine this is a wall and has water this much, and immediately above it, there's a hole. Through this hole, water can leak out. But as the water amount is only this much, it doesn't. Now, if I put my boat inside this, the water's area increases and comes till here. So, if I put this inside the bar, it will sort of increase the area because this thing needs a volume. So the volume it takes, more the place decreases. So water rises up. As there's a hole here, water will start coming out of it. So again it will come to this. Again it will come to a position. Now I'll rub off this area. Rub this all. And now you see the water will come supposedly here. And the boat is there. And if you keep a cup over here, and supposedly the water will fill this much. That. So, this means the area this dome shapes displays in water is equal to the water over here. The water in here is equal to the area it displays in the water. So, if this boat takes a displacement that's very high, but it takes a higher displacement, but has a lower density, the buoyant force, which is a force that acts on it, will make it float. If the buoyancy in this float, if I want to make it clear what's buoyancy, it's nothing but if I have water here and something over here, just this shape, there will always be a force acting on it in this way. This force is called buoyancy. Easy and simple. No more definitions and all that. If you want it, you can take from here. It's just that if the displacement of this object in water is higher than its density, the force given by water that makes an object float is called buoyancy. Just easy. The force that water acts on an object upwards is called buoyancy. This buoyancy can be seen everywhere. If you see a duck feels buoyancy. Anything, even if you put a rock in water, even though it sinks, it's feeling a force towards its bottom, so it can rise up. But the buoyant force. So if I have water here, just about here, I put a rock inside, it sinks. If you say that there's no buoyant force on it, that's wrong. The buoyant force is there. As the ball lands, a buoyant force is given here. But if the weight is equal over here, like how is it in the boat, it will float. But that's not the case in stone. Its mass is 4 times. Let's imagine. In this case, this force cannot control. It's like holding a rock, holding a very big brick with two spaghetti sticks. So it falls down to the ground. This is why rocks sink. It doesn't mean that rock feels buoyancy. It does feel buoyancy, but its weight is higher than its buoyant force, so it sinks. So every object feels buoyancy, but it sinks or floats according to its mass. If you see, if you have a bottle that's without air and you put it in water, if you have a bottle of water, you put an air-filled container, it will float. But as soon as you have a syringe and put it in water, it is the same. Now comes the change. You pull the syringe. So what happens? While pulling the syringe takes in the water and increases its weight. So as it increases its weight, the buoyant force is the same, but the mass of it increases. So its buoyant force cannot control it, and boom, the object sinks in. This is how subs work. Submarines use the same technology. Buoyancy is the main thing that's used in submarines to get in and get out. If you have the same syringe and push it off all the water, boom, it will come back again. The buoyant force will act on it and it will start floating again. So this is called buoyancy. It's a force that water acts on objects and push it upwards. But lesser the mass, it floats. Higher the mass, it sinks. Thank you guys for today's episode. This is a 14 days challenge. Continuous 14 days. There will be videos posted except for Friday and Saturday. But in the other days, all day there will be a continuous posting of all the videos. 14 days challenge. And in the last 5 to 4 days, all the inventions, ideas will be collaged to make a new robot. This robot will be the ending scene and the challenge will be over. Then we'll come back to our old, new-fashioned videos on topics and many inventions made by me. This kit will be very helpful for me, and with more circuits that I buy, we can make controllable robots and many things. I am excited for the 14 days challenge. The first day has been successfully finished today. From tomorrow, it continues. Tomorrow, a new robot, and the other day, and the other day. This is a 14-day challenge. After these 14 days challenge is over, the last 5 to 4 days, I work on a robot that's a collage of all the robots, and then do a new robot that's has the eye of all robots. It can be a boat that can walk, it can be a car that works like a crab, and it can sometimes do crazy things that we'll see at the end. So it's the end for today, and we will see a video of this boat going in a lake in the next part. This is a purely solar powered boat. As you can see, it works with the gear ratio and torque and the photoelectric effect of the solar panel. As I move it towards the shadow, it stops. Move it towards the sunlight, immediately it moves. This is because as the sunlight stops, the power gets stopped. So immediately the motor stops. See the leg movements? If you were to remove the boat, it would look like a human paddling.